Hey there, this is Horner, and we're going through 1996 M1. This is a problem that deals with an inertial balance. So if you remember, an inertial balance is just a device that helps us measure the mass due to an inertial movement. So the inertial movement that we have on this one is simple harmonic motion. This one bobs up and down. The one that we have in our lab bobs back and forth from left to right. Let's go ahead and see what it wants us to do. It talks kind of a little bit about the experiment, and then it says they want us to fill in the blanks in the data table. And they give us a couple things that we need to fill in. The first one is the period. And so to find the period, notice this is the average time for not one vibration, but for 10. So all we're going to do with each one of these is just divide by 10. So you don't have to do this. This just helps me so that I know what I'm dividing by. So I'm dividing each and every one of these by 10. So this would be 0.886, 1.06. Next one is 1.35. Then we have 1.47, and then finally 1.77. If we square each one, we get 0.785. We end up with 1.12. We have 1.82, we have 2.16, and then finally 3.13. That is actually worth 2 points, so you get 1 point for filling the period in and 1 point for filling in the period squared. So that one's pretty simple to do. Our next problem that we have to solve is they want us to plot t squared versus mass and then draw a line on the graph that is a best estimate of the best straight fit line to your data points. So in order to do this, we need to go ahead and just look at our points that we have, or look at some of the things that we could generate our points with. So let's move this graph down just a little bit here. I know our data points are a little bit messed up, but that's okay. So the first point that we need is about 0.866, and it occurs at a mass of 0.10. So we're just going to put a dot right here. And then the next dot will go at the 0.2 mark. And notice that it is about, this is 0.785. This would be about 1.12. The next dot should be at 0.3 and 1.82. The next dot should be at 2.16, which is somewhere around in here. And then finally at 0.5 and 3.13, which is somewhere around in here. So the next thing they want us to do is to go ahead and plot a straight line. So I'm going to grab my straight line tool because I just think that's a lot easier. And our straight line needs to go through and approximate kind of where those points are. So we're going to start right here. And you should have some dots on the top, some dots on the bottom, and it should extend all the way through the graph. And so ours does at this point. I'm going to need to move this over just a little bit because the program doesn't allow me to keep it where it was. Now I've got my best fit line. This is actually 3 points. So one of the points was plotting the actual points themselves. One of them is drawing a line, and one of them is having dots both on the top and on the bottom. So you'll notice that I have a couple dots on the top and a dot or two on the bottom. And they call that a very, very good best fit line. For the next part, so remember we said that was 3 points, so we can actually write 3 out of 3 is what we got on that one. So we're on our way to a 5 on this exam. Next thing we need to do is take a look at the next part of the question. And it says an object whose mass is not known is vibrated on a plate. We see 10 vibrations is about 16.1 seconds. So at this point, we can just go ahead and say, well, I know that I need to take this number divided by 10, and so our period here is equal to 1.61 seconds. Then we can go back up to our graph. So I'm going to cheat a little bit. I'm going to grab a different graph that I have on a separate page. This one actually comes from the key, so it's a little bit better graph. They've done a little bit better job of showing us what it looks like. And I'm going to go ahead and put that one over here. So I've got to paste it. I'm going to grab a hold and just paste that graph in. So now we can see it. And they want us to try to figure out with 1.61 seconds about what that value would be. So here we know that 1.61 seconds was our period, so this would be 1.61, and we need to actually square that. So we need to square that value. Let's make this look like a 1. And if we square that value, end up with 2.59 seconds 2.59 squared seconds. We need to do that because remember our graph is a graph of t squared versus the mass. 2.59 would be somewhere in this area here, 2.59. If we go over to our graph, that 2.59 would be somewhere about in this area. So from this, it looks like we've got probably a point right there, and we see that that's about 0.45 on our scale for mass. So we're going to put 0.45 kilograms. Okay, and this part is worth 2 points. So as long as you have the 0.45 kilograms and you have the 2.59 seconds squared, they give you both of those points, which is really nice. For letter D, we're going to skip it, and we're going to go ahead and go to letter E. And it says, can this device be used to measure the mass aboard the Space Shuttle Columbia as it orbits the Earth? And your answer for this one is absolutely. And the reason that we can do this, so you need to say yes, it can be used. Don't just put yes. So we need to put yes, it could be used to measure mass. And it says aboard the Space Shuttle Columbia. So here we're saying that measure mass in a low gravity environment. Sorry if you can't read that. So yes, it could be used to measure mass in a low gravity environment, and they want you to explain briefly. So all you have to do is say the oscillation, or that moving. So oscillation, the oscillation does not depend on gravity. Instead, it depends on the springiness of our little device. So those are the two things you need in order to get those last 2 points. And that is how you answer that very simple AP Physics problem.